please remember there may be a chances of opening the college at the end of the semester. So may you have the exams. So I think you ready to write both online or offline, whatever may be. Okay. So serial communication. Anyone remember what are the serial registers we have seen? Serial communication register. Did anyone remember? I have put one more register here. Did anyone remember, ma, what are the serial communication register we have discussed in the first unit? Did anyone remember?
Yes, ma'am.
Yeah, tell me, ma.
SBUF, ma'am. Serial
As
Data Buffer Register.
serial data buffer, and then
SCON,
SCON, very good. SCON
Apram,
register,
PCON, ma'am. Power Control Register.
very good, very good. Bhavana, you said, who have said, ma?
JST, ma'am.
Jayashree, very good, Jayashree. So serial data buffer, serial control register, PCON. Okay, that is power control register. All these are related to the serial communication registers. Okay, so today we will see one program how to send the word. I have already told you how we were communicating with the help of this register. Today we will see one serial communication program. Then next we will discuss about the question paper, university question paper. Are you clear? I'm going to discuss only first two units because almost while you are seeing the syllabus, addressing modes over, instruction set over, IO programming is input output program is over, simple programming is over. Simple programming, addition, subtraction, multiplication, division, and like a logical programming and all swapping, complementing, all this, all lab programs are very sufficient. Then we will see the some university question paper, and we will see if any other program is there. We will discuss that program alone. Are you clear? So today is serial communication and timer. IO programming means we have seen LED and light, stepper motor rotation, DC motor rotation, and on the day I didn't show that output of that. Yesterday there is a problem in 7 segment glowing, but the program is correct. Okay, no need of worrying and all. We will try to do while you're doing in the lab. Okay. For actually power electronics lab you are supposed to do in you have to come to the college and you have to do, but embedded there is a chances if they allocate the lab we will do it in online itself because we know the programmings. Okay, so now serial data buffer register, participants reach 65, so we will start. I will explain you one serial communication program that is not only the program for theory, it is for your lab also. Okay, so we have a three register. What Jayashree said, serial data buffer. That means it's a 8-bit register. Just it will hold the serial data during transmission or receiving. We all know here we are following full duplex communication. That means microcontroller have a capability to send the data as well as microcontroller have a capability to receive the data. Okay, so serial data buffer register will act as a sending the data as well as receiving the data. There is no modes of operation in this register. We have clearly explained in first unit, but anyway, it's a small recap for you to understand while you are moving on to the program. Then serial port control register, that is SCON register. Serial port control register. Na, this particular register is mainly used to set the mode of the serial communication. So the first two bits is used to is used for modes of operation. So modes of operation, 2 bits allocated for modes. So we all know 2 bits now, 4 modes of operation: 00, 01, 10, 11. So mode 0, mode 1, mode 2, mode 3. Okay, so mode 0 is a shift register. You all know baud rate. What is baud rate, ma? The bits per how many data sent bits per second. Actually, how we will define baud rate now? Baud rate is nothing but how we were receiving or sending the data, that will be calculated bits per second. Okay, so here the baud rate is divided by 12 oscillator frequency, and here I can vary my baud rate. Okay, And here I have a baud rate in two ranges, divided by 64 or divided by 32 means two range of baud rate is there. And here variable means various range of baud rate is there. Okay, so first one is shift register operation. We all know shift register. I told you what is shift register now. Shift register will, while whenever it is receiving and sending the data, it will hold the data. Okay, but here UART communication will comes under mode 1. UART means what, ma? Anyone tell UART? What is UART? What is UART, ma?
Universal Asynchronous Receiver Transmitter.
Very, very good, ma. Very good, ma. Register number 15, Bharata. Okay. So here we are sending 8-bit UART. Okay. So here 9-bit. Actually, we can able to send only 8-bit only. Along with that, we have to send start bit, stop bit, and all that I didn't include. But 9-bit means it can able to send only 8-bit. So if it is 9-bit means I have to enable this 2-bit. TB8 or B8. Did you all remember? If I want to send the 9th data, whether it means be in transmission or receiving, I have to send it here. Okay. REN. What is REN sense means? It will enable the serial operation. Okay. So SM2 for multiprocessor communication. So mode 2 and mode 3, there may be a process of multiprocessor. At that time, we will enable. Okay. Then TIRI. TIRI is nothing but two interrupt flag. One is transmission interrupt flag and another one is receiving interrupt flag. So during interrupt only this flag, during transmitting and receiving one, transmitting this flag will be enabled, receiving this flag will be enabled. Are you clear, ma? So only thing is to recap, already this explained only. PCON. Okay, you just see PCON as the is also a 8-bit register. Mainly here we all know the timer one register is mainly used for serial communication. Okay, so in timer we have seen a four modes of operation: mode 0, mode 1, mode 2, mode 3. In mode 0, 13-bit timer will be used. Mode 1, 16-bit timer will be used. Mode 2, 8-bit auto reload will be used. Mode 3, what happened? It is a shift. Actually, we will split the timer and we will use. But mode 2 is normally used for serial communication. I think here I have put it for your purpose. See, the third mode, 8-bit auto reload mode, na, this mode is mainly used for serial communication. Are you clear? So normally mode 2 in timer we will use for serial communication. Okay. So here they have fixed the baud rate. Okay, if I put -1, the baud rate is 9600 bits per second will be transmitted. If I fix -6, 4800, -12, 2400, -24, 1200 baud rate. So if I want to double the baud rate, I have to keep my serial mod bit as a 1. If I fix this bit as a 1, my baud rate will be doubled. 9600 into 2, 4800 into 2, 2400 into 2. Okay. Now we will go for the program. I think the three register we have seen: serial buffer register, serial controlled register, power controlled register. But while power control register will be always used in the backend only. If I set 1 or 0, I can, if the serial mode value is 0 means the actual baud rate will be used. If the serial mode value is 1 means the baud rate will be doubled. Are you clear? So normally we will use only two register: SCON register and SBUF register. I have seen SCON and SBUF only we will use in the program. So see, this is a program to transfer S. Okay, if time permits, I will try to explain. I will try to show the output in the. I will try to show the output and tomorrow or day after tomorrow, Monday, I will show how it is working in a serial communication. Okay, so we will have a small demo. So now you see, I'm going to transfer. Yes, this is nothing but transferring. This program is receiving. So two program only we are going to see for serial communication. You just see the programming will be very simple for you. That is the only advantage in the microcontroller. The coding is very, very easy. Even 8-bit addition, it takes 2 lines. So it is very easy for you to write the coding. Okay. So first T mod. Okay. Timer mode. I am just assigning. I'm going to use which mode, ma? Mode 2. We all know the mode 2, especially auto reload mode, is used for serial communication. So I am assuming, I am assigning timer mode register to 20. So we all know 20 means what? 0, 0, 1, 0, 0, 0, 0. So 1, 0 means that denotes that we are using mode 2 operation. Okay. Then TH1 minus 3. Minus 3 means I told you minus 3 means you see what is the baud rate ma? 9600 baud rate. So this value. So here TH1 minus 3. Minus 3 means we were saying that 9600 baud rate is used. 1 minute ma. Sir, thanks. So TH1 minus 3 means 9600 baud rate. Ma'am, you may ask, ma'am, this value I have explained again. It will take a time to explain it all. Well, see the unit 1 PPT, how I can put FD or minus 3, how this value is assigned. I have taken one example and I have explained you. Okay. So those who have forgot that, go and refer the unit 1 PPT. We can see that how we were fixing this baud rate and all. Okay. Then move SCON. SCON means what? Serial controlled register. So 50H. So 50H means that is 8-bit one stop actually serial controlled register. This is the value. Okay. 50 we have assumed ma. 50 means how will you write? SCON value is what ma? 50. You just go here. 50 means what will be the value? 0, 1, 0, 1, 0, 0, 0, 0. Are you clear ma? This is 50. This is 50 ma. So 50 in sense means here 0, 1. 0, 1 means which mode I'm going to use? I'm going to use mode 1. Are you clear ma? I'm going to use mode 1. Mode 1 means what? That should be 8-bit UART. Okay. Why I put 1 here ma? Why I put here 1? 1 means what? 1 refers which bit? REN. REN means what? I have to enable my serial operation. Can you understand? If I am assigning any value, backend there will be an register format is there. You may ask, ma'am, how they are saying this and all. You all understand? A manufacturer will decide which port, which bit has to allocated to which mode, what operation has to be designed. Everything will be predefined by the manufacturer. So the Intel manufacturer itself will assign all these bits. So this and all we have to know what bit where they are allocating, how we were using. That is the only thing. So the backend and all decided by the manufacturer only. So 0, 1 means you have to understand that we were using which one mode ma? Mode 1 operation, and we are enabling the what ma? We are enabling the serial communication. Okay. Then set B TR1. Okay. Set B TR1. TR1 sorry, TRI means what ma? Start the timer 1. You have seen I am going to start the timer 1. That's why I put set B TRI. I'm not going to take any. We all know timer 1. We are allocating set B TR1. Okay. Now we are going to send what we are going to send. Yes, I have to send. So you just see move A comma hash Y. Okay. So transferring yes. We all know we always transfer the hexadecimal value or decimal value. So the first time we were putting the character Y. So we will see how it is working in the delay program. Move A comma hash Y. A call. A call means what? You understand? This is my delay program. So trans means automatically it will come to the delay program. In delay program, what I am doing ma? I am moving my accumulator value to SBUF. SBUF means what? Serial buffer I am moving. Okay. And then JNB TI. We all know TI means what? Transmission interrupt flag. So every time I am checking whether Y is transmitted or not. JNB means jump on no bit. Till TI is 0, I have to wait. Whether it is send the data, I have to check each and every time. So here the loop is in the once it is sent means automatically TI becomes 0. TI becomes 0 means it will come to the next line. What is the next line ma? CLRT, clear the TI. Then return. Return means what? Once again it will come back to the main program. Then next letter what it will send? E. Okay. Then once again it will come to the delay program. Delay program, accumulator will send the data to serial buffer. Whether it is transmitted or not, we will check through the TA flag. Once it is transmitted, now exit from the flag, and then we have to clear the value. Okay, so then it will once again return back to the main program. So this process will be keep on executing. Are you clear, ma? Can you understand? Then yes jump again means once again I have to start my program. Okay, so when I executed this program, my yes will be transmitted throughout the yes will be transmitted from where we are transmitting now, there it will transfer. So what we, once again, okay, what you have to understand now. So first, what you have to understand now, first we have to assume the mode of timer 1, then we have to fix the baud rate, then serial control register we have to set the serial control, then we have to start the timer. After that every character I have to send. So the character accumulators will send the data to serial buffer, and then if it is transmitting, I have to check the ta flag. Okay, then once again if all the characters sent, the program will over. So my program to transfer yes serially at what baud rate ma? 9600 baud rate, and 8-bit data. Okay, I'm sending because mode 1 na 8-bit data, mode 2 and mode 3 only. You have seen mode 2 and mode 3 only 9-bit data. Okay, mode 2 means mode 1 means 8-bit data only, and we enabled the serial bill communication. Okay, so this is the program we have explained with the transmitting. Now receiving the program, you just see the same thing. Tmod 20, tmod 20 means smart ma, the same thing. Timer 1, mode 2. You always remember mode 2 is exclusively for serial communication. Then th1 -6, -6 means, you just see, -6 means what is the baud rate? 4800. So the baud rate is 4800 bits per second. Then SCON 50, 50 means what? Mode 1 is enabled. Okay, and REN is also enabled. Then start the timer. Okay, instead of JNB TA, we are receiving here. So which flag I have to check? Receiving interrupt flag, JNB RI here. Every time I have to check whether I am receiving any data. So whenever RI is 1, what happened? I will get the data from, I will receive the data. Then once again I will receive the data from serial buffer. I will move to accumulator, and accumulator to port 1. You all know if it is a character means it will display the ASCII value of that. Okay, then clear. Once I have received it, I have to clear the interrupt and yes jump here. Are you clear? So you imagine, I'm sending yes means y e s and all single character, but it have a capability to receive 9600 bits per second, can able to send the data, and 4800 bits per second to receive the data. So within a second I will receive 4800 data. Within a second I can send 9600 bits. Can you understand or not? So that much data is can able to send as well as receive. So these two programs are very sufficient for serial communication. Okay, so if they are serial communication, you have to tell some introduction about SBUF, SCON, PCON. Okay, and the timer also. Timer we all know, mode in mode 2 operation is very much important for serial communication. So we always use timer 1, mode 2, auto reload mode for the serial. Okay, now uh, we will discuss some university question paper. Okay, actually I have put all the questions here, but slowly I have reduced the question. You all know, did remember anyone remember the pattern? University, because you have written after a long back only, you have to write your exam. Did anyone remember ma? Party, how many questions?
Ma'am, 10 2 marks,
Okay,
5 16 marks.
516 marks, very good. Actually don't this is your senior, because only your two batches only there for this particular thing. So the remaining question I have taken from your before the batch. So 516 marks, so totally you'll write for 100. Okay, we'll see some university question paper ma. Okay, compare microprocessor and microcontroller. Can anyone remember microprocessor, microcontroller difference? Please, anyone tell me. Not much difference, at least one or two difference. Yeah. Yes. Actually,
Microprocessor is less costly than microcontroller.
microprocessor is
It costs less than microcontroller.
microprocessor.
Microprocessor uses
Hmm.
a von Neumann architecture, ma'am.
Very good, very good.
Microcontroller uses Harvard architecture.
Harvard architecture. Very good. Von Neumann means we used to say we don't have a separate program memory and data
Yes,
memory.
ma'am.
Okay.
Yes, ma'am.
Any
System,
other? Ah,
system on chip. The entire RAM and ROM is occupied on single chip.
very good.
Whereas in microprocessor, we don't have like that.
Yeah, very good, very good. In microprocessor, we have a on-chip memory, but microcontroller we have a on-chip memory, but in microprocessor we don't have on-chip memory. We are using Harvard architecture. That's why we have a separate ROM and RAM memory. Okay, very good. Any other difference?
Then microprocessor uses a lot of voltage, like it takes a lot of power, ma'am. And in controller, it doesn't take much of power. It has power saving mode, idle mode, ma'am.
Very good, very good. Actually, consumption, we don't have a power saving and idle mode is there. So what that will do now, that will stop the clock. So what happened means automatically the power will be saved. Okay, very good. Any other difference?
மெமரி இன்டர்னல் போர்ட்ஸ்ல எக்ஸ்டர்னலா கனெக்ட் பண்ணும் மேம் மைக்ரோ ப்ராசஸர்ல. மைக்ரோ கண்ட்ரோலர்ல இன்டர்னலா இருக்கும் மேம் மெமரி.
Yeah, memory is internal. Memory, we have to interface the memory in microprocessor, microcontroller, internal memory. Very good. One more point, very important point I need. I'm not getting that point.
Microcontroller is the heart of embedded system.
Yeah, very good.
Ma'am, bit handling instruction is less in microprocessor.
Bit relating microprocessor, we don't have any bit related instructions. No bit related instruction, but microcontroller we have such an instruction. Okay, that's good. One important point is
microprocessor have less number of registers, ma'am. Microcontroller,
yeah,
more number of registers.
Yeah, that's true, because we don't have a bank register in microprocessor. That's correct. One important point, in microprocessor, if I want to interface, I need a interfacing IC, but microcontroller we don't have interfacing. Directly we can connect the motor, directly I can connect the LED, all. So that is very important point. No need of any interfacing ICs in microcontroller, because we have a ports. That structure is not available in microprocessor. Okay, very good. Those who said the answer, very, very good. Okay, list the various forms of memory present in a system.
Internal memory, external memory.
Internal memory, external memory.
Okay, okay. Internal and external memory. Internal also we have a ROM RAM. External also ROM RAM is there. Okay. Internal RAM having 256 bytes and internal ROM having 4 KB. But when I go to external ROM and having 64 KB. Okay. So very good. And then write an 805 to add two numbers. Add two numbers. I think it's very easy program. Actually, if I want to add, move a comma hash 22. Okay. And move R1 comma hash 33. Okay, 33 assume. Add
A, R.
R1. Very good. That's it. Only 3 lines. I am assuming A equal to 22, R equal to 33, add A comma R1. Very good. What are the IO programming devices, ma? What are the IO programming devices? Input output programming devices. What is the meaning of this? I input output, whatever I am connecting to the microcontroller, all are programming devices only. IO input output programming, what are input output programming devices, ma?
Timer.
Yeah.
Clock.
Time. timer, serial ports, analog to digital converter, digital to analog converter, whatever which is interfaced in the microcontroller, all the IO programming devices. Okay, very good, ma. Then next we will see part B question. Explain the architecture of 8051. It's very important question, ma. Okay, so then you see, discuss the following counters. You see, counters means you all know counter or timer. Both are same answers only. Don't get panic. Counters and timers are same question only. So you have to explain the 4 modes of operation of timers. Okay. Then serial input output interrupts. You have to explain about the interrupts. I think the first 2 unit we can predict the question. Only this question they will ask. Okay. Explain the second unit, addressing modes. You all remember, don't forget this question. Addressing modes is a default question in all the question paper. So while I'm starting the second unit itself, I told you. Then see, what is the second program? Second choice. 8051 to arrange the number in ascending order. Okay. So I will, okay. I have put this program in ascending order. Okay. You just see, actually this is, okay, one second, wait. Okay, so here they have taken 10 datas. Assume from 20. Okay, so 20, 21, 22, 23, 24. I'm going to take the consecutive locations. Okay, my data is 66, 33, 44, 22, 11. Okay, I'm taking only 5 datas for your reference. Okay, ascending order. So ascending order 20, 21, 22. This is, you all know, this is my address. Okay, and this is my data. Okay, now how we were doing ascending, please, because it's very important question they are asked in repeated university question. So R4, A means what, ma? In the count. How many data I'm going to assign, ma? 10 data. That's why I put A. Okay. Then again I am moving R3 also A. R4 is also A. R3 is also A. So R4 and R3 equal to 10. R4 and R3 equal to 10. 10 data I'm going to assume. 10 datas I'm going to put. Okay. Then move R0 comma hash 20. So what is R0 value? 20. CLRC. That means what? What is CLRC, ma? What is CLRC?
Clear screen.
Clear screen.
Wow. Clear screen. We are doing MATLAB.
Clear carry, ma'am.
Clear carry flag.
Okay, ma'am.
Clear the carry flag. Don't say clear screen and all. We are doing in MATLAB. You didn't forget the MATLAB. Okay. Move A at R0. At R0. What is my accumulator value now? Do you tell me? Move A at R0. At R0 means what? At 20, what is the data? What is my accumulator value, ma? After executing this line, move A comma at R0. That at R0 should move to accumulator. So what is my A value?
20H.
20H is address.
66.
66. You all understand 20, 21, 22, 23, 24. They have taken internal memory. That's why. See, most of the program we will use internal memory. Why? Because now external memory we have to interface. Okay, so most of the program they will use only internal memory. So at R0, at R0 indirect addressing mode. So what is my accumulator value? 66. Okay. Move A comma R1. What is my R1 value, ma? R1 is also 66. Okay. INC R0. INC R0 means what? R0 is 20. So now INC R0, now R0 will become 21. Then move A comma at R0. Now what is my accumulator value, ma? What is my accumulator value? Move A at R0.
33.
Very good. What is so I am going to compare R1 and accumulator value. R1 is 66, accumulator is 33. These two value I am going to compare first. Okay, now sub B A comma R1. Sub B A comma R1 means what? A minus R1. Sub B A comma R1 means what? A minus R1. So I am subtracting accumulator minus register. Okay, jump on no carry na, no problem. Accumulator content actually after ascending, actually what has to become a ascending order means what? Ascending, which has to come first?
33 first.
Yeah, 33 has to come first. Very good. So if I subtract 33 minus 66, I can understand the first number is greater than the second number. So I have to swap the number. Can you understand or not? I have to swap the number. That's why I'm subtracting 66 minus 33. So if I subtracting 66 minus 33, if accumulator content is greater, no problem. I can skip it. Or else, okay, I can skip. Skip in sense means where it will come, jump on no carry na. I have to go to the next memory location. Okay, but here what happened? If I subtract 66 minus 33, carry flag will set. Am I correct or not? So this condition become fails. So move A comma at R0. So at R0, I have to move to accumulator. So at R0, I have to move to accumulator. Now what is my accumulator value? Accumulator is 33. Okay. Then why I am moving ma? After subtracting, my accumulator will store the subtract value only. So I don't want to have that value. I need only 66 and 33 alone. So once again, I'm moving my at R0 to accumulator. So accumulator is 33. Then DEC R0. DEC R0 means what? Decrement R0. So R0 will become 20. So move at R0 comma A. I have to move my accumulator to at R0. So at R0 value is what? 20. So my 20 is now 33. Are you clear? Then move A comma R1. A comma R1 means what? What is R1 value? 66. That is move to accumulator. Now what is my accumulator value? 66. Then move at R0 comma INC R0. INC R0 means what? R0 will become 21. 21 means what? It will go to the next memory location. So next memory location, I have to move my accumulator to at R0. At R0 means what? Now that will become 66. Can you understand or not? Then how long I have to execute it? DJNZ. DJNZ means what ma? Decrement jump on no zero. This loop has to be keep on executed. 66, 33, 44, 22, 11. Okay. So you have to understand that so 20 is having 66, 33, 44, 22. Once again. Actually problem is so I have taken only 5 data, ma. So you understand that this is input. So after executing my program, my output, how it will become? First, it will compare 66 and 33. So what happened now? 33 and 66. Okay. Then it will compare 44 and 55. Is it correct only? So it will take 44 and 55. It will then it will compare. It will compare the consecutive memory, ma. Then it will compare 66 and 44. Then it will compare. Then what happened? We have to shuffle the data. So 44 has to come first and 66 has to come later. Then 66 and 55 will compare. Then what happened? 44, 55, 66. Then it will compare 66 and 11. So what happened? 44, 55, 11, 66. Then we have, that's why we have done, this is for one rotation and that is internal loop. Then it will check for external loop. Are you clear? So here, what instruction is mainly used to compare? Sub B. I will subtract the first two value, whether carry flag is set, I have to swap the data. If carry flag is not set, then automatically what I will do, I will move on to the next data. Have you understand? Actually, this program is very, very important program. So the program is very simple only. Just we are loading one value, two registers for count. Okay, one will check the inner loop and another will check the outer loop. Then one value is stored in accumulator, another value is stored in register. These two will be subtracted. So after subtracting, what we have to check, ma? We have to always check whether the accumulator content is greater or less. So depending upon that, if carry flag is not set, automatically I can go for next data. If carry flag is set, means accumulator containing the small data, automatically I have to swap the data. That's it. Okay. Then next one is, see the next question paper. We will see, ma. I think this question paper is so okay. This question paper we have completed. Okay, this is the next question paper, ma. Please, did you remember the program? Write a time delay routine for 1 millisecond using timer 0. Yesterday I have you. Yesterday I think day after before. How we have to check set the time delay. This is a assignment question I have taken from here only. Can you understand? Okay, what are the types of memory available in 8051? Same question, ma. What are the types available? What are the types of memory available, ma? Students, what are the types of memory available?
Internal memory, external memory, ma'am.
Yeah, the same thing. Internal and external memory.
External.
How can IO pin both act as a input and output? Your assignment question only. Input means the particular pin had to be configured as a 1. Output means the pin has to be configured as a 0. That is port 0 operation. Okay. Explain data transfer instruction. Tell me some data transfer instruction, ma. Please give me some examples for data transfer instruction. Data transfer instructions. Angeline. Yeah. Tell me, ma. Move. Move is a data transfer instruction. I can move accumulator to registers, or registers to accumulator, or accumulator to internal memory, or internal memory to accumulator, or accumulate or register to internal memory, or internal memory to registers, or else I can move the data from accumulator to external, and is external memory, external RAM memory. That external, what are the data transfer instruction, na? What are the instruction we will use? Did you, I think while we are writing, we can, what are the main instruction, na? Move, we will use move X for external location, move C, external coding memory. So these are the data transfer instruction, very popular instruction. Exchange instructions also there, but these are the three important instruction: move X, move C. Move means between registers, between registers, between internal memory and all. Move X means external RAM memory. Move C means external code memory. Okay. So did you remember this question? What are the resources available? How are they interfaced inside? You all understand all the questions. If you know, see, 11 and 12 are same questions only. But the resource available in 8051 means you have to you have to especially explain the features of 8051. Followed by that, you have to explain the architecture. But see the next question, same architecture. Okay. Now explain the different addressing modes. So second unit, very important question is addressing mode. Now you see, add two BCD number and save the BCD result in RAM location starting at 40. Okay. We will see this program. Okay. I'm going to add two two datas. Okay. Now you tell me how many bit data, ma, it is. 95 means how many bit data? Maunika.
2
If
bit,
I'm
8 bit, ma'am.
huh?
8 bit, ma'am.
8-bit data. Very good. But here, what is my number? 197795. Now, how many bit? This is one 8-bit, 8-bit, 8-bit. So totally
32-bit.
32-bit is there. Okay. So instead of, we have to assume that we are going to add two 32-bit numbers. Are you clear? So while we are adding, how we were adding now? This is the addition.
Ma'am,
34,
24.
25. What ma? Okay, sorry. It's a 24 only. Because this is 16-bit, 16, sorry, 24-bit only, ma, 24-bit only. Okay. So now we are going to add this number, BCD addition. Okay. So first what we have to do, I have to add this two number. Are you clear? Then I have to add this two number. Then I have to add this two number. So I have to perform how many 8-bit addition? How many 8-bit addition, ma? 3 8-bit addition. After that, I have to convert it to BCD. BCD means which instruction is used, ma? BCD, na, which instruction is used? BCD addition, which instruction is used?
Boolean.
DAA. BCD instruction, DAA. So you remember, first I am adding 95 and 48. Are you clear? Then I am adding 77 and 45. Then I am adding 19 and 34. Are you clear? So I have performed 3 addition. Okay. Then to convert that, every time I am putting what, ma? DAA, decimal adjust accumulator. But you have seen, I have to store it in which location, ma? 40. So you all understand, after addition, my answer is 54, 23, 43. This is my answer. Okay. So I have to store it at the location on 40. 40 means, you just see, 40 I have to store what value? 43. 41 I have to store 23. And 42 I have to store 54. This is my BCD number. Have you understand? So what I did, ma? Move R0, comma 40. We all know, after addition, my answer will be stored in accumulator. So I moved from accumulator at R0. At R0 means first content is moved. Then next I have to put INC R0. INC R0 means what? 41. Then again I have to move. So 23 is stored. Then INC R0. Then once again 42 will come. Then at R0. Then 64. Very simple program. We performed 3 8-bit addition, and then we have put DAA, and then we put move at R0, comma A. Automatically the value is stored. So this is also one of the important program. See, addressing modes means you have to write some 4 or 5 pages, then only you get the mark. But what is the advantage of writing the programs now? If you write your programs very correctly, then automatically what happen, if it is a 16 mark, they will give 16 mark. They won't reduce the mark. That is always the difference between the problems and theory. If the problem is very correct, or the programming is correct, even though they are not going to debugging the code, they are not going to execute the code, just they will check the logic. The logic of the program is correct, now obviously you get the full marks. Okay. So this program is over. The next one, see, same question, compare microprocessor and microcontroller. Explain the different types of timer. What are the timers, ma? What are the different types of timers? Tell me, ma, what are the different types of timer?
Timer 0, timer 1.
Very good. That's it. Timer 0 and timer 1. Very good. Then what do you mean by immediate addressing modes? Immediate addressing mode, what is the example, ma? Tell me. Immediate addressing mode. Immediate addressing modes. Anyone tell, ma? Immediate addressing mode. Hey, how many
Move
instructions?
A, comma.
Ah,
Move
ash 50H.
yeah. Move. Hash is the only thing. Hash. Hash is the symbol used for immediate addressing mode. Then explain data transfer. We have seen now only. See, explain the functional unit timer / counter. Both are same only. That's why they have explained timer or counter. Okay. Interrupts. How many interrupts are there in 8051? How many interrupts, ma?
5, ma'am.
Yeah, very good. 5 interrupts are there. See, the same program only they asked here. Okay. Now you see the next program. Write 8051 assembly language to evaluate the expression. See, I think this program. This is the program they have given. A into B plus C. Okay. A into B means which program I have tried? A into B, ma?
Multiplication.
Multiplication. Then I have to add the data. Very simple. So what I am going to do now, my A is 45. Are you clear? My B is 35. Okay. My C is A5. Sorry. Actually, I'm writing now. I have a. Okay. My A is 45. My B is 35. My C value is A5. That is the thing. So I'm going to, so what I do, I put 45, 35, mul AB. What happened? 45 into 35 I will get. After 45 into 35, what is the answer? 04E49. We all know the lower order byte will be always stored in accumulator and higher order byte will be always stored in the B register. After multiplying 45 into 39. Okay. Then next what I did, I get the C value. Add A comma R1. Add A comma R1 means what is my A value? 49. Absent எடுக்கல sir. Ma'am எடுப்பாங்க. கவிதா மேம் நீங்க அட்டெண்டன்ஸ் எடுத்து சார் கிட்ட சொல்லிடுறீங்களா? நான் அது மட்டும் சொல்லிட்டு போயிடுறேன். சார் ஆக்சுவலா நான் இப்போ கிளம்பிடுவேன் மேம். ஒரு 2 minutes சார் மேம் கொடுத்துருவாங்க. ஓகே. So now what happened na? So I'm going to add my C register value. What is my C register value? A5. So I have to add this too. So after adding this, what is my answer na? EE I will get. Okay, this and all I have assumed. Okay, then this EE should move to where ma? 40. So 40th location, I am moving my EE value. Okay, then 41 location, what is the answer? The next way, 0E. I have to move the value to move A comma B. I have to move this value to accumulator and accumulator to at R0. At R0 means I have incremented. Incremented the R0 now, the value will become 41. So actually the answer is triple E. 0E. That's why I have taken. This is the fancy data. Okay, that's why I have taken. So you see, very simple program. First, I have multiplied. Then I have added this two data. Then I have finally moved my data to B register. That's it. Okay, you can use very simple data also because they said finally you have to get the 16-bit data. That's why I got this is one 8-bit data and this is one 8-bit data. So totally 16-bit data I'm getting. Yes, clear, ma? Okay. So you have seen interrupts, PCON register, context switching. That is nothing but full duplex, half duplex, and all we are saying now. That is then see you see T mode registers. They are explained about the T mode register. Then you see architecture. Architecture timers. It's how you see this question is repeatedly they are asking. So you have to be study architecture timer ports. All ports they ask ports as well as timers. They asked both ports. Now you have to explain about port 0, port 1, port 2, port 3. Okay. Then you see addressing modes. Addressing mode is a default question. Then ascending order. Okay, and you have seen add the given two BCD number and store the result in BCD form. Only two BCD number na I can take 8-bit number also. Very simple program. Move A comma hash, move R comma hash, then add A comma R1, then DAA. DAA means what? Decimal address accumulator. Okay. Then exchange the content of memory location 1000H8 and 2000H. Actually, it's a very simple program. You just go through it. Tomorrow I will if just note down this program, exchange the content, I will ask this program, or else you just take one snap. Tomorrow I will ask anyone to explain the program. Okay, anyone or I'll whoever I am asking, you are supposed to answer. Yes, every time we were explaining now, just note down this program, take the snapshot, then you will see. Okay ma, I think now ma'am will come. நீங்க வந்துட்டீங்களா என்ற now Kavita ma'am will take the attendance for you ma. Please give the first hour attendance to her. Okay, then she will take second hour separately. So this attendance is for first hour. By giving first hour, don't leave the class. Ma'am will take the second hour attendance at middle or at the end. So give the attendance. Okay, thank you ma. And tomorrow Friday, so once again definitely you have a quiz will be there. So prepare for the quiz and come. I didn't tell the results, yesterday's result. That will be I will tell you on tomorrow. Okay, ma. Akash Singh, switch off your video or else sit properly. Ma'am Kavita, ma'am, kindly take the attendance for the first hour, ma'am.
Okay, ma'am.
I didn't take. Please give to
Okay,
Sundarajan
ma'am.
sir, ma'am.
Okay.
Thank you, ma'am.